Okay, now the second question is, let A, B, C be the set such that A union B equals A union C, and also A intersection B equals A intersection C. Show that B equals C. Now see the solution. What is given? That this is given A union B equals A union C. So we start with this A union B equals A union C. Now our next step is that we take intersection C on both sides of the equations. So this will be A union B intersection C equals A union C intersection C. Now see, by applying distributive law, now this is the left hand side, this is the right hand side. Now applying the distributive law on this, we will get A intersection C union B intersection C. Now again, distributive law, as I have discussed in my previous videos, you can just check it. Similarly, A union C intersection C. Now see, A union C means combining the elements of A and C. Now if we take common C from it, what we will get? We get C only. A union C intersection C will give you C. Now A intersection C is equals to A intersection B. This is given in the question. So we can replace A intersection C with A intersection B union B intersection C equals C. So basically our C is A intersection B union B intersection C equals C. Okay. Now again, what is given is A union B equals A union C. Now in the next step, what we will do is that we will take intersection B on both the sides. Now A union B intersection B equals A union C intersection B. Now again the same theory in this, the same theory, like if you take A union B and you take B common, so that will be B only. So this is B equals, now applying distributive law in this, you will get A intersection B union C intersection B by distributive law. But we can write C intersection B as B intersection C. That's the same thing. So basically this B is equals to A intersection B union B intersection C. So if you take this as equation 1 and this as equation 2, as you can see, C is what? A intersection B union B intersection C, and B is the same, basically the same. A intersection B union B intersection C. So by equation 1 and 2, A equals, really sorry. From equation 1 and 2, B equals C. So the next question is, show that if A is a subset of B, then C minus B is a subset of A minus C. So let's start the solution. So we can start with X belongs to C minus B. Okay, so let X belongs to C minus B. So in the next step, that means X belongs to C, and because since it is minus B and X does not belongs to B, again in the next step, X belongs to C and X does not belongs to A. Now why this step? Because A is a subset of B. So every element of A is already in B. So if X does not belong to B, X will definitely not belongs to A. So we can write this as X belongs to C minus A. So from this and this, X belongs to C minus B, X belongs to C minus A. That means C minus B is a subset of C minus A. Subset sign is like this. Yeah. C minus B is a subset of C minus A, which is the proof. Now, next question. Assume that PA equals to PB. We know that P is the power set. The power set is a set containing all the subset of a given element. The power of A equals to power set of B. Now we have to show that A equals to B. So in this case, what we will use is that, see, if the two set are the subset of each other, then A and B are equal. Like if we can prove A is a subset of B and B is a subset of A, and A equals to B. Okay, so let's start. So our solution start with let X solution. Let X, small x, basically small x, B and R, B, T, R, A, R, Y. I'm sorry, I will write this again. A R B I T R A R Y, arbitrary element of A. Okay, so X be an arbitrary element of A, then there exists a subset. Now then there exists a subset capital X. So we can denote that by capital X. Okay, such that X belongs to capital X. Now are you getting this point? X is an arbitrary element of A, and what is this capital X? This capital X is a subset of A. So it's obvious this is small x belongs to capital X, which is the set. Now small x belongs to capital X means X is the subset of A. So that means capital X belongs to PA. That's obvious, capital X belongs to PA. Now from this, PA equals PB. So capital X belongs to PB. That means capital X is the subset of B. Now here comes the small x. Now small x, this implies that small x belongs to B. Okay, so x belongs to B. So this implies x belongs to A, as we have taken, and x belongs to B. We can write this as A is the subset of B. Now again, as the above, let Y be an arbitrary element of B. Now there exists a subset capital Y, subset of this set, such that small y belongs to capital Y. Okay, so that means Y, capital Y, is the subset of B. Just a second. Capital Y is a subset of B. That means this Y belongs to PB. Now PA equals PB. So PB Y belongs to PA. Now this Y belongs to PA. That means Y is the subset of A. That means now small y, you can write it like this, belongs to A. So here y belongs to B. This implies y belongs to A. Hence B is the subset of A. So from equation 1 and 2, A is a subset of B, B is a subset of C, hence A equals B. Hence proved. So next is, the question is it true for any set A and B, like the power of set A, if you take the power of set A union power of set B, will be that equals to power of A union B. First of all, I want to say that PA union PB is actually not equals to PA union B. Okay, now we have to prove this also. So why this, we'll take an example, and we will take a very simple example. Now let A be 1. So this is a set. B is another set whose element is 2. Now we have A, B. We can write A union B. A union B will be 1. That is A union B. Now you have to write separately. Like, see, what will be PA? We know that this is a power set containing all the subset of an element of any set. So A, we have phi and 1. This is power of A. PB, power of B, will be phi 2. We take power of A union B. This will be phi 1. Sorry, actually these are the sets. Really sorry for this. Okay, so this is power A, power B. Power of A union B. This is A union B. 1, 2, 1, 2. So this is power of A union B. Now if you take PA union PB, okay, got it? PA union PB. This will be phi 1 and 2. As you can say, see, PA union PB is phi 1 and 2, which is clearly not equals to this. Hence, PA union PB is not equals to P of A union B. Proved. So next question is, show that for any set A and B, A is equals to A intersection B union A minus B. You have to show that. And A union B minus A equals A union B. Okay, so first we'll take with this part, which is A equals A intersection B union A minus B. So you know that this is LHS, this is RHS. So we'll start with the RHS. We'll take the RHS. A intersection B union A minus B. Now the thing is that A minus B can be written as A intersection B dash. These are from the Venn diagrams only, like A minus B is equals to A intersection B dash. So A intersection B union A intersection B dash, as A minus B can be written as A intersection B dash. Now applying the distributive law. Now if we apply the distributive law in this, what we will get is A intersection B union B dash. This is actually the reverse of distributive law, as we have discussed, as I have again I am telling you that I have discussed in the previous videos of the sets only, of the theory part. So A intersection B union B dash. Now what is B union B dash? B union B dash is a universal set. So what we will write is A intersection the universal set. Now what is A intersection universal set? Which is A only. Hence the first part is proved. So we started with RHS, this equals to A. Moving on to the second part, which is A union B minus A equals A union B. A union B minus A equals, now we have to prove that A union B, that's fine. Again B minus A. Now this B minus A can be written as B intersection A dash. So A union B minus A, you can write this as A union B intersection A dash. Now again applying the distributive law. This will be A union B intersection A union A dash. Now again A union A dash will give you the universal set. So this is A union B intersection the universal set. Now again A union B, if you do A union B intersection the universal set, you will get A union B only. So and second part is also proved.